Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. So we have been covering the topic time series, and in time series, we have covered the topic measurement of trend. Now, the second component of time series were periodic variations, in which there were two components. One was seasonal variation, and the other was cyclic variation. So, moving on further, we'll start with the measurement of seasonal variations in today's class. There are also four kinds of methods that is very important for seasonal variation. The last one has been repeated many a times in the PYQs. So we'll begin it today. So let us begin. So measurement of seasonal variations. If we want to measure the seasonal variation, we have to keep in mind the two points. First point is that we have to determine the seasonal components or variation. Firstly, we'll determine what is seasonal component or what is seasonal variation. And the second one would be remove the seasonal component from the given time series data. So first of all, we'll determine what are the seasonal components, and when we'll receive that, then we'll remove those seasonal variations from the time series data in order to make our time series a better one as compared to the previous one. Okay. So there are now four types of methods for seasonal variations. Method for seasonal variations. To first method is method of averages, or we can say that method of simple averages. In each class we'll do one method. It's I'm giving you the outline of this. In each class we'll do one method, and merits and demerits of that method, and one example of that method. This is how we are going to complete four different methods. Then the second is ratio to trend method. Then the third one is, and the fourth one is link relative method. And the fourth method is ratio to moving average method. Okay, so there are four methods: methods of simple averages, ratio to trend method, link relative method, and method to moving average, ratio to moving average method. So first of all, we'll do method of simple averages. We'll cover this in today's class. or we can say this is a method of simple averages. There are four steps in method of simple average. First of all, that we have to arrange the data in accordance with months or years, whatever it is given. First of all, we'll arrange the data in accordance with the month of or year. The spelling is wrong. Then, second, compute the average of ith month or year, whatever you have. The question says we have to compute the average of ith month, which is given by x bar I. Then the third part says that we have to compute the average of the monthly averages. Compute the average of monthly averages, which is given by x bar, and hence it is given by 1 upon n summation I goes from 1 to n x bar I. This might sound very confusing right now, but keep on holding on as we'll solve one problem, then all the steps would be clear. I'll simultaneously tell you what are the how do we uh, see the how do we do the rules, how do we connect the rules with the example. I'll simultaneously tell you. So and the fourth one is compute seasonal indices which are a percentage of the monthly average. So these are the four steps which we'll follow in the question. So let us take an example. We have been given a month and production in lakhs of tons of. So we have been given months. Let us make a table. So the question says that we have been given month Then according to month, we have been given the data for 2002, 3 and 4, 2002, 2003 and 2004. Here we'll calculate the total of these data. Here we'll calculate the monthly average, and here we'll calculate seasonal indices. So the data has been given for January, February up till December. March, I'm writing till June so that you can understand. We are not expanding this. April, May, June, December. And let us take this is as total line. So in 2002, the values given are 12, 11, 10, 14, 15, 15, 12, 11, 10, 14, 15, 15, and so on. 15, 14, 13, 16, 16, 15, 15, 14, 13, 16, 16, 15. And the last one is 16, 15, 14, 16, 15, 17. 16, 15, 14, 16, 15, 17, and so on. So first of all, we'll calculate the total of all these we have arranged. Okay, now we'll move to steps. First step was to arrange the data in accordance with months or years. So we have arranged the data in accordance with months. For first month January of all the years, for second month February of all the years. Likewise, we'll arrange the data. Now, what is the total? What are the total of these? This is 43, 40, 37, 46, 46, 47. 43, 40, 37, 46, 46, 47. Guess this is the right way. Yes. So the monthly average would be, we'll divide this. Suppose this is column 1. So monthly average would be 1 divided by 3, because there are 3 years in 1 month. So we'll divide it by 3. So 43 divided by 3 will give us, okay, I'll write here for the first step. 43 divided by 3 will be almost equal to 14.33. And 40 divide, again we'll do 40 divided by, so it will be 13.33, then it will be 12.33, then it will be 15.33, then it will again be 15.33 if we all divide it by 3, and then it will be, sorry, 15.33, then it will be 15.66, and so on. The first step is clear. We have calculated the average of ith month. We have calculated the total and then average of ith month. So first month is January. For January month it is 14.33, for February it is 13.33, and so on. And then the third step involves compute the average of monthly averages. Now we have to total this as well. So the total value which is coming is 492 of the totals. It is total value 492, and if we take average of this monthly average, we'll get 163 0.95. We have not written all the values, so I'm just writing directly. 163.95 is the monthly average. Now this monthly average, uh, since this is the monthly average, these are the averages of all the 3 years. We have to calculate for 12 also, for all the 12 months as well. So we'll divide this by 12. So after dividing this by 12, we'll get the xi bar, oh, sorry, x bar as 1 upon 12. It is nothing but 1 upon n summation I goes from 1 to n xi. So 1 upon n is 1 upon 12. Summation I goes from 1 to n xi is nothing but 163.95. So it will be 163.95. And from here we will get that our value is 13.66. So this is our x bar, and this is how we have calculated the monthly average for all the months. If the months would have been two, if only for January and February it would have been given, then we would have divided by 2 instead of 12. Now what? How do we calculate the seasonal indices? Seasonal indices are the percentage of the monthly average. So this is the monthly average. Then seasonal indices for January can be calculated as seasonal index for January. So seasonal index for January would be the percentage monthly average for January 14.33 divided by this monthly average which is 13.66, and we'll multiply it by 100 because it is a percentage of monthly average. So after dividing it by that, we'll get 104.886 as the answer. 104.886. This is the seasonal indices for January. If we have to calculate the seasonal indices for February, it would be seasonal index for February. It would be the monthly average for February, which is 13.33, 13.33 divided by the monthly total monthly average, which is 13.66, and multiplied by 100 because it is a percentage again. So we will get the value as 97.56. And similarly we can get for all the months. So it would be 104.886, 97.56, 90.247, 112.205, 90.447, 110 point. Okay, after this you can calculate on your own. And the total of seasonal indices should also come 1200. Why it will come 1200? Because it is we are calculating for all 12 months, so 12 into 100 will be 1200. If you would have been calculating for quarterly, it would have been 4 into 100, which is 400. So this is how we calculate seasonal indices. Now there are merits and demerits of this methods. Merits, that it is easy to compute, and demerit, there is only one merit of this is a easier method, and demerits are not very practical in use. It is not, this method is not used practically mostly. This is the first demerit. The second demerit is it assumes Absence of trend. Cyclic component. Okay, there is one more merit is that it removes the irregular component by averaging. If we do average, then irregular component gets removed. So it also removes irregular component. So it assumes the absence of trend and cyclic component, which is generally not the case. So this is not the case where trend is mostly present in the time series data. So it falsely assumes that they are absent. So this was your first method of simple average. In the next lecture, we'll cover another method with one example and merits and demerits, as I told you earlier. So I hope that you have been that you have been covering the topic simultaneously from your books. Keep on practicing and keep on learning. All the best. Thank you.